My Audi RS3 has had a tough life. Not only was intentionally crashed, but I found the reason why. When I first started the engine, I immediately noticed it didn't run well, and as I kept investigating, it wasn't good news. There was a misfire on cylinder 1. I tried changing the spark plugs, swapping ignition coils, until eventually I did the ultimate test, a compression test. Since then, I had no choice but to get the engine out of the car and start stripping. Eventually, I found this. A broken piston on cylinder 1. Today, my RS3 engine looks nothing like it used to before. I had it stripped, cleaned, measured and machined, ready for a full engine rebuild. But since I can't really put the old parts in, I have a solution for that. Inside this box is everything I need to rebuild my RS3 engine and make it run again. What you see is the ultimate RS3 engine build kit that can sustain up to 1000 horsepower. We have new pistons, new rods, new bearings and a full stud conversion kit. Before I can actually put any of this inside my engine, I have to make sure that my brand new pistons are well balanced. And with that, we have to pay someone a visit. So let's go and see George. We are at George's place and now we're gonna measure the weight of my JE pistons. I'm going to measure the weight of all 5 pistons and check if there is anything more significant than 0.1 of a gram. If there is, then we're gonna have to take some material from the heaviest and match it to the lightest. I'm only going to correct tenths of a gram and not hundredths because I'm not sure I'm going to be able to do it as precise. I started by measuring the pure weight of each piston. I took 5 measurements so I can make sure they are consistent. I then took the average of 5 and noted it down. Pistons are measured and as you can see there is a slight difference in the weight. What I'm going to do next is I'm going to include in that measurement the wrist pin, the piston rings as well as the wrist pin locks, and that whole assembly should now give us the right measurement. Now the reason why I do that is because I can't really take material off the wrist pin or from the piston rings or the wrist pin locks as such. So the only place we can take weight off is from the pistons itself. So now I'm going to repeat the process and then we'll see what's the total net difference in the weight. I then gave each piston and its components such as the wrist pin and the piston rings a number and started measuring them all together at once. That would give us the weight of the whole piston assembly, and by doing that we'll know how much we actually need to remove from the piston itself. So I've just finished measuring all of these and now as you see piston number 5, 459.4 and 459.6 on piston number 4. Now everything else as you see is pretty much the exact same. Now I'm gonna take 0.4 of a gram from piston number 4 and 0.2 grams of piston number 5. You can see guys where I've taken material off just on the inside of the skirt here and here. Don't go to this edge because this is where the conrod is in contact, so just do these outside edges and try to do it as uniformly as you can on both sides. So here it is guys, piston number 5 was 305.2 grams and now as you can see it's 305. So we've taken 0.2 grams, so now piston number 5 is equivalent to piston 1, 2 and 3. I'm going to do the same procedure for piston number 4. I repeated the exact same process of removing material until all 5 pistons were exactly the same weight. Both pistons are now in spec. I've taken 0.4 on this one and 0.2 on piston number 5. All piston assemblies now have the same weight. The next step is to go back to my garage and start adjusting the piston rings gaps. Thank you very much to George for letting me rent his tools and I'll see you in my garage now. And would you look at that? It's so oddly satisfying to look at this when they're brand new. I am back in the garage with all my pistons balanced and having the same weight. Now the next step is to install the oil squirters on the bottom of the engine, but before I do that I want to do one final spraying of the engine with the brake cleaner just to make sure everything is nice and clean. But I don't want to bore you with this, so we are diving straight into installing the oil jets. These must be torqued to spec, but they're very easy to install. And here they are. Now that the oil spray jets are in, the next step is vital, and it is the adjustment of the piston end caps. Now this we have to do by putting these segments one by one into each cylinder. We're gonna oil that up so it's not dry, and then we're gonna measure with a gap filler what is the gap, and we're gonna adjust it according to this sheet which is provided by the manufacturer. And there are different applications. So as you can see here, we have a table with the application and the corresponding gap of what it should be. Now I'm only going to build a high performance street strip, so we're gonna aim at that clearance there for the top ring, for the second ring, and for the oil ring. First step is to oil up the cylinder so we don't ruin the fresh honing. From then on, it's a repetitive process of putting each piston ring one by one inside the designated cylinder, squaring it with a squaring tool to the active area or the working area, which is approximately 15 mm down from the deck, and then measuring the gap with a filler gauge. Since a proper piston ring file is about $1,000, I had no choice but to use this manual file grinder, which I picked up from eBay for about £70. If you want my advice, be extremely careful with this. They remove so much material with only a partial turn of the grinding wheel. So always do a maximum of 1 to 2 turns and check again in the cylinder. Until all 5 pistons were ready for assembly. All of the piston rings are now filed and set. Now the next step is to put all of that together, and then we can start putting it in the engine. So let's go. You can hear all the heavy breathing, because that is the most difficult task for building an engine. The struggle here was real. Me and my dad spilled blood, sweat and tears over this, until finally I got the gist of it. Let me show you. So the easiest way is you put it on a flat surface, you take one of the locks, you put the lower part inside like this, just so that it's about there, just like that. And then as you start to push with the screwdriver in, apply pressure with this thumb. And a few attempts later, you have it. 5 of the cylinders already have one of the locking pins in, and now the next bit is to put some assembly loop onto these and start assembling it with the con rods. Only half of the job is now done. After everything is put together, we can move to another batch of locking pins to be installed. Only this time your grip is restricted and you're trying not to ruin more than just one expensive part. But sometime later, it all came into place. 3 pistons are now fully assembled, the locking pins are inside, and I have just found the best way to do this. What we do is we put it here, I then apply pressure so that it's in the channel. I apply pressure with my thumb here to go inside. Although it seems crazy, believe me, this is the most clean, effective and painless method to go about this. It was then time to install all piston rings onto the piston and get them ready for assembly into the engine. All pistons are now fully assembled, all piston rings are on the pistons, con rods are in, all of the locking pins are in. The only thing left to do is to install the con rod bearings. Just for information, the ACL con rod bearings are coming in one size. And also make sure the seats are clean. These are fairly simple to install, but it's mandatory they sit flush on both sides and precisely in the middle of the con rod. The next task is identical, so we start with cleaning the main bearing seats on the block. All pistons and con rods are now fully assembled, all of the piston rings are installed, the con rod bearings are also in place, and now the next step is to actually start installing the main bearings onto the crankcase and onto the main bearing journals here. And this is where we have to be mindful of something, and this something has to do with the clearances for the crankshaft. And Audi has a special way of designating the clearances, so let me show you what I mean. On the side of the block there are 6 letters which indicate the size and the position of each upper bearing clearance. The same goes for the lower ones which mount on the caps, only this time they're displayed on the crankshaft. The crankcase bearings are actually different than the main journal bearings. And now for the crank bearings we have a special designated code here. 6 B's, and each letter corresponds to a special color. Now in our case B corresponds to blue, and that's why we have here 6 blues. Now the main journal bearings, they have 5 B's and 1 V, which is basically corresponds to violet. And now we have to be very careful where we put them. The first letter here corresponds to the first bearing here, and they follow the same sequence all the way to the last. All upper bearings have now been installed. Now the only thing you have to be mindful here is that when you do install these, they have to line up absolutely perfect here on both edges. There's no anything sticking out or sitting lower than it should be, and that should be absolutely spot on. After all upper main bearings are installed, it's time to do the same with the lower ones. I first start with the violet bearing, so I can get it out of the way. I have checked exactly where it goes, so I install it, and then I can move to the remaining blue ones. Always double, even triple check which part numbers goes to the upper side and which goes to the lower one. Just finished installing all bearings, both on the crankcase and the main journals, and now the next step is to put some studs on. The studs should be hand tight only, and I use the ratchet just to make sure all of them sit at the bottom, so no torque applied at all. And since I'm using ARPs, they go in with a little bit of the ARP fasteners loop. So now that all of the main bearings are in and the studs are in, the next step is crankshaft. Before dropping in the crankshaft, it's absolutely vital we don't forget to put engine assembly lube. And in goes the crankshaft. The next step is installing the thrust washers. We've got a brand new set. We have lower and upper ones. The upper ones do not have any tab here, whereas the lower ones they do, and the lower ones actually sit in this groove here. Make sure the grooves are facing the wall. I do it similarly to what I've seen on YouTube. I put assembly loop and stick it to the wall, then I just push it until it's rotated in position. I then do the other side, and it's done. And just like that, we have 2 thrust washers installed. Next step is putting the lower thrust washers onto the main journals. We're gonna stick it again with this grease, and we're gonna start putting all of these back in the crankcase. The lower thrust washers have a tab which sits in the groove. I use the same technique and stick them to the side with the assembly grease. not forgetting to put assembly loop onto the bearing and the crankshaft itself. I then push it as further as I can by hand and tap it lightly with the rubber hammer. Then we move on to put assembly loop on the remaining crankshaft journals and bearings, and I use my finger to spread the loop evenly. I then install all remaining bearing caps and start putting fasteners loop onto the studs and the tightening nuts. After that, it's time we torque everything down to spec. In our case, 60 foot-pounds of torque in 3 equal stages, following the prescribed sequence. Finally, is the additional bolts on top and the side of the casing, which have both torque and angle values. The time to install my piston assemblies has finally come. The last remaining step before the pistons can actually go inside the engine is to position the piston rings in a special order, and this order is described here. So I just did the first piston. I'm gonna start from cylinder number 5 because it's the closest to me. If we check this image, it says top compression ring is on the right side. As you can see, the top compression ring is here. The second compression ring is on the opposite side, as you can see is just there. And then finally the oil rings are scattered at the bottom left corner and the top left corner, with the middle spring on the right side. And now that should be ready to go in. Now the tool I'm going to use to install my pistons is a product by Wiseco, and this is a ring compression sleeve which has the exact diameter of the bore, and that is 82.5. Now this has a cylindrical outboard edge but a conical inboard edge, and as you push the piston down through that, it compresses the rings until the desired bore diameter, which is in our case 82.5. Make sure that the cylinder walls, the sleeve and the pistons are very oily. You can't really put too much of oil. And in goes the first one. I position the sleeve so that the bottom skirt of the piston is sticking out slightly. That will be my guide so that the sleeve is concentric to the cylinder. I then apply pressure with my thumbs until the piston is inside. Don't push the piston too further down, as you can hit and scratch the crankshaft with the conrod edge. And one by one, all pistons went inside the block. I then rotated the engine on its side so I can align the conrods to the crankshaft into installation position. Prior to that, we put assembly loop on all crankshaft journals and each bearing cap. As you can see, we've just managed to basically install all the clamshells for the conrods. We're not gonna tighten them yet. We just wanted to make sure they are in place so we can rotate the crankshaft. And now the next step is we're gonna undo these. We're gonna put some of the ultra fastener assembly loop, and then we're gonna start torquing down. The conrod clamshells are also secured with ARP bolts. Normally there are two ways to go about torquing these. The first method is to torque the bolts until a desired bolt stretch is achieved. The second one is the traditional method where we torque to a given Newton meter value. The best and recommended way is to tighten these using the stretch method, but since I didn't have a stretch gauge, I did it the old-fashioned way,
that the
using torque values.
And conrods are all in and torqued down. The next step is to start putting on the chain drive components, and the first one to go in is this one, which is basically a sprocket which helps with the high pressure fuel system and the vacuum system.
This sprocket is crazy expensive, so I'm careful not to damage it. It has a groove and a stick out pin which should line up.
The next stop is the oil pump, and now in order to do this we have to replace this little seal here.
I can then position the oil pump back on the block and loosely fit the bolts so I can make adjustments. If you remember from my engine disassembly video, I took measurements at 2 points, which would give me the exact position of the pump. I then aligned the pump to these exact measurements and triple, even quadruple checked.
Oil pump is tightened to spec, chain sprocket is tightened to spec, this is in place, and now it's time for the chain.
We have a brand new chain kit for this engine. It just wasn't worth to put back the old ones. So in goes the lower chain first.
The next stop is to change the old chain tensioner. We have a brand new one from Audi, so this is going in next.
The chain tensioner is hydraulically driven by the oil, so it's good for it to be torqued to spec, 9 Nm to be precise. I then did a small turn on the crankshaft to check if everything is going smoothly, and it did. On to the next task, fitting the upper oil sump. After giving it a very good clean from the old silicone, it was now ready for a fresh silicone beads to be applied on all sealing areas. After we've secured it in position, it's time to install tons of bolts and torque them to spec. Once the upper oil sump is fully torqued down, it was time to install the oil pump funnel, of course with a brand new seal. I poured a small amount of clean engine oil in the pump, so it's not fully empty. Finally, it was time to apply new sealing beads on the lower oil sump panel and put that back into place with another million of screws surrounding it.
The upper and lower sump are now on, the tightened sealant is applied, and now the next job is the sealing plate on the pulley side of the crankshaft.
Of course not without another set of silicone beads, so here we go again. This is a plate by Victor Reigns, and for some reason it was missing a hole, and apparently it was intentional, as all of them do. Nevertheless, I didn't figure the reason. We tightened the bolts and job done. Finally, it was time to install the side casing, and yet another bit of silicone has to be applied here. I rushed to install the torque panel, but as usual not without another harsh lesson. And now let's see how many of you spotted the mistake. For those of you that did, you were right. I forgot to install the upper chain before I close off the area. So another hour wasted of cleaning freshly applied silicone on both the casing and the block. So here goes round 2, only this time we don't forget to put the chain first. We torque everything in sequence and to spec, and we're good to move forward.
The bottom end is finally complete, apart from one last piece which we are missing. We're actually missing the tool for, and that is the crankshaft main seal. I do actually have the seal itself, but I'm missing the tool and I don't want to ruin this, and that would be the last missing piece to get this bottom end completed. So if you enjoyed this video, make sure you've subscribed to the channel if you haven't already, hit that thumbs up button, and I'll see you in the next video where we're gonna be doing the first engine start, hopefully. So peace out.